This one. So this is the integral from -1 to 4 of this graph. -1 to 4. That is this area plus this area. Notice the negative area. Negative area is going to subtract out. Okay, so the question is, what is the total area under this curve?
So find the trapezoid and then find the trapezoid and then subtract.
Or mentally just kind of start adding and subtracting areas.
So you got 2. Oh, wait. That's half. What?
This is positive, this is negative. Answer? 2.5. All right, so the important thing is just adding and subtracting. This one, they have this function. This function is such like this. The question is, first one, g of 0. When they're asking g of 0, they're saying plug in 0 for x. Okay, plug in 0 for x. So we want the area under the curve from -3 to 0. So trapezoid.
2, 1, 3.
9 over 2. I did not get 9 over 2.
2 plus 1, 3.
Yes, I think it's not over 2.
Over 2. Over 2.
I think I got 6.
What?
9 over 2? Oh, I'm sorry.
I keep getting
Okay. What about this one? G of 2. G of 2. G of 2 means from -3 to 2. All right. Next week. So, we didn't finish this one. Okay, G of 2. So we said G of 2, well, G of x is, again, according to this function here. So basically, it's just saying that x is 2. So you just put 2 into that integral. And so the question is, G of 2 is really just the integral from -3 to 2 of f of t. And f of t is this graph that's shown. So basically, it's saying what is the area under the graph from -3 to 2. Okay, -3 to 2. -3 is here. It's going to be this part. -3 to 2. So we got to add up all that area. All right, this part. What is the area here?
We figured it out last time.
Thank you. What was it? 4.5?
Something like that.
Was it 2? Sorry, 2 plus 1 times 3 divided by 2.
Yeah, 9 over 2.
9 over 2. And then this part. There is a semicircle there.
The rectangle.
Just do a rectangle, yeah.
Yes, rectangle minus the semicircle. Yes. Yeah, so the rectangle is 2 minus semicircle.
Isn't it pi r squared over 2?
Pi r squared over 2. What is r?
You need half of it.
Oh, no, she already divided by 2.
Oh.
R is 1.
R is 1, so pi over 2. Okay, 2 minus that. So basically, it's going to be, okay, so G of 3 is going to be 9 over 2 plus 2 minus pi over 2. So this area plus this area. Oh, sorry, G of 2, sorry. Okay, good, easy. It's just kind of looking at a graph. If it's a negative area, again, goes under the x-axis, you got to subtract. All right, we're going to just look at some properties of definite integral. These are pretty simple and very intuitive. First, integral from a to a of f of x. What do you guys think? What is the area? Yes, 0. You're starting from here, ending here. There is no area. You made maybe a line, but not even a line. It's just nothing. So From the same place to the same place, the integral is nothing because there's no area. That's the first property. Second property, this is just showing you. So this is just the integral. It's okay. It's equal to if I were to switch the limit. So the lower bound and the upper bound. If I were to switch it, so it's b to a instead of a to b, and then I left everything the same. So basically, I'm integrating instead of from left to right, I integrate from right to left, or basically I just do the opposite. Remember, a has to be smaller number than b, right? That's how integrals written. If I swap the two end points, then then I put a negative in front. So basically, it's the negative of the area because I'm instead of going this way, I'm going backwards. Yes. The area. Okay, so when we talk about the area under the curve. Yes, area is always positive. No, when we do integral, remember if you're below the x-axis, it's negative. So the sign matters. So the sign matters. So if you're going this way and you're looking at the area, when you go backwards, we're going to say that's the negative area. Yeah, flip the limits. Next one. This one's also very intuitive once I show you how it looks like. Let's say that, let me draw it farther away. Let's say that this is f of x, and a is here, c is here. And let's say b is in between. And we are trying to figure out the area from a to c. It's very simple. Since b is in between, it's just going to be the area from a to b plus the area from b to c, right? Pretty obvious. So the area from our integral from a to c is the same as saying that the integral from a to b, f of x dx, plus b to c, f of x dx. That's if b is in between, right? The area, the total area is the first area plus the second area.
Seems like common sense.
It is, yeah. It's just when you're applying these, you have to find that trick in your problem, which is sometimes the hard thing. Okay, so let's say number 4. K is a constant. When k is a constant, you can take it out of the function, so it's easier to integrate. And so these are the rules I wrote on your warm-up. So if you're adding and subtracting an integral, you can just split this into 2 integrals. Sometimes it's just easier to integrate that way. The last ones are a little bit harder to understand. So stay with me. Number 6. If f of x is greater than or equal to 0. F of x greater than or equal to 0 means you have a function that's always above the x-axis. That's what it means. You have this function that's always above 0, meaning it's higher than the x-axis, somewhere up there. And you're trying to integrate from a to b. So basically, you're saying that this function is somewhere up here. It's never going to go below the x-axis, and you're trying to integrate from a to b. Then, since f of x is always positive, when you integrate, your area is also going to be, dx. Your area is also always going to be greater than or equal to 0. Because if your function is up here, you're trying to find this area. This function is higher than 0, then your area must be higher than 0. Right? So then the opposite is true. If your function is below, then when you're integrating, it's always going to be negative. All right, next. If you have 2 functions, f is lower than g, meaning you have a function here that's f is lower than g, then when you integrate, the area is also going to follow the same theory. So then from a to b, the integral from a to b of f of x dx has to be less than or equal to the integral from a to b of g of x dx, right? Because one area has to be smaller than the other area. Yes?
Yeah.
Because it's just kind of thinking about how it looks like it has to be true. And then last one, you probably didn't even know this would have been a problem. So it says, if f is continuous on this interval, or if f has a finite number of jump discontinuity. Okay, what does that mean? So let's say your graph looks like this. It has a jump. And you're trying to integrate from here to here. Then that looks kind of strange, right? How am I going to integrate? It looks like there's a discontinuity. It says if there's a finite number of discontinuity, so finite means that there's just that amount, like not infinite, then you can actually still integrate. Just break it into 2 and then add the areas together, which is okay. So then f is integrable on a to b. So then that means the integral from a to b of f of x dx. So basically it's saying that you can just integrate. All right, we are ready to apply. So let's look at some problems. Huh? What? Oh, okay. Okay, first one. If the integral from 0 to 10 is 17, integral from 0 to 8 is 12, find the integral from 8 to 10. All right, so this is very simple. If you can see that this is the same as saying from 0 to 8 plus from 8 to 10. This part is 17. This is 12 plus this we don't know. So that part, yes, subtract. So for integral from 8 to 10, keep forgetting dx, must equal 5. So it's just breaking up that integral into smaller pieces. Okay, good? Okay, next. Find the integral from 0 to 5, and you have a piecewise.
So at the split it up.
Split it up, yes. So from 0 to 5, well, it splits at 3, so then this integral from 0 to 5 is the same as saying from 0 to 3, and then from 3 to 5.
So can we say 3 even though it's not at 3?
Yes, because this is the finite number of jump discontinuity.
It's not a jump distance.
Is it continuous?
Yeah.
Oh, yes. In this case, it would even
Yeah, but
be.
even if it's not.
If it's discontinuous, it's fine because it's just a jump discontinuity. If it were discontinuous, then you can't. Then you need the next class to integrate. Okay, so we know that from 0 to 3, that is 3. From 3 to 5 is x. You need to draw a picture right now because you haven't learned how to find the answer. So you need to draw the picture. The curve is 3, the curve is x. So you have to find the area under the curve. Okay, so the first one, the curve is 3 from 0 to 3. So this is just a square. The second one is x from 3 to 5. So that's going to be a trapezoid.
Oh, okay.
Yeah. So the answer is 17. Are you guys okay?
Yeah.
Okay. All right, next. This one's a little tricky.
Oh,
Subtract.
Oh.
Okay, this one, think about the curve. x minus 3. X minus 3. So x minus 3 looks something like this.
Yeah.
So there's something below.
There's something below. So you gotta subtract. So from -2 to 3, it is below.
Oh crap.
And then from 3 to 5 is above. So you gotta find that triangle that's negative, and then the triangle that's positive, and then add them together. So please be careful of the negative area. So this area that's negative is -25/2, and this part is 2. So add them together, you get -21/2 or -10.5. Okay, now what if you don't have a graph and you don't want to draw a graph? Then you figure out when this is flipping over the x-axis. So just x minus 3 equals 0. So then x is 3. We know that it's going to change from below to above at 3.
Well, I did like.
All right, last two. If you have this function, and they tell you that from 0 to 5, this area is 4. What is this? Huh? No, 8.
What?
Split this, right? Split it.
Oh.
4 plus 2x.
No, plus 2 dx.
Yeah.
Okay?
Oh,
14.
it's 30. Yeah.
This is 4. This is 10. Right? The
Yeah.
length is 5. The height is 2. So 2 times 5 is 10. That's a rectangle. So 4.
How did?
It's given.
The define function of that.
Okay.
All right, let's try a different one. If f is even,
I don't know.
what does even mean?
Oh, not odd.
Like this, right? Left-hand side is the same as right-hand side.
Oh.
Like mirrored.
Like a parabola.
So what would be this?
2.
The area from here to here is 4. It's 8. Because it's double,
Okay.
right?
Oh. Because they're both sides.
Because it tells you it's symmetrical, right?
I thought it meant like even.
Okay, yeah.
If it was odd, it'd be 0.
If it were odd,
It'd be 0.
it would be 0 because your graph is going to look like this, right? So then this part is 4. This part is going to be -4. So this is going to be 0.
Okay.
So
4 from
the original problem.
Oh.
Oh.
Listen.
All
Glad you're-